Okay, so for the third question, let's consider what kind of alternative energy solution we could have for Ohio, other than coal. So the question before us is, in Ohio, coal-fired electrical sources, coal-fired generation, yields about 4 million megawatt hours. That was the figure from May of 2018. All right. Well, considering that the mean daily insolation, that's the amount of solar radiation we're getting from the sun, falling over Ohio, is 3.5 kilowatt hours per square meter. How much area would we need to cover with solar panels that have about a 15% efficiency in order to generate the same amount of electricity, that 4 million megawatt hours? Well, here we got to come to grips with a couple things. First of all, remember that a megawatt hour equals 1,000 kilowatt hours, because a mega is a million, so 1,000 thousands is a million. And this unit is actually energy. So it's a power times time. It's an energy unit. It's non-conventional, but it's non-SI unit, but it's conventional because it makes more sense when we look at our bills. So, all right, the other thing to remember is that this unit is a flux density, sort of. It's an energy per square meter. So it's also that non-SI unit of energy, kilowatt hour, per square meter or per area. All right, so, and then of course, the solar panels are only 15% efficient. So these are the key pieces of information that we have to work with. The way we tackle this question is we could say, okay, basically remember this is a month of May, that's the energy per month that we're getting. And this unit is literally kilowatt hours per square meter per day, because that's assumed when we talk about the daily insolation. So mean daily insolation. Okay, so let's just remind ourselves that that's kind of got a per day assumption going on here. All right, so let's start with our 4 million megawatt hours. And of course, that's in a month, the month of May. We want to get to kilowatt hours, so what do we do? Well, let's convert units. Let's get our megawatt hours at the bottom so they cancel out. Remember that 1 megawatt hour is 1,000 kilowatt hours. Now, our kilowatt hours units and our area is what we're considering here. If we have 3.5 kilowatt hours per every 1 square meter, okay, per day, the day is up here, because the day was down here as a square meter, but we want to then think about dividing through by this number to figure out how much area we need. Now, we have our efficiency factor to consider. We're only 15% efficient. So in this case, we want to take 15% of that. So we can add our efficiency factor right in here. And then, of course, our month variable over here, let's assume 31 days in May. May has 31 days. Remember that? January on your knuckle, February, March, April, May. All the knuckles are 31. Anyway. June, July, August, September, October, November, December. That was a freebie. So if we do all this math, notice what happens for the units. Megawatt hours are canceling out. We've got a kilowatt hour canceling out. We end up with our day canceling out and our month. And the thing we have left is our area term, and that's what we're trying to solve. So we end up with a number of square meters, and You can check my arithmetic. But that's the area of solar panels that we need. Now, if you wanted to figure out how many square kilometers that is, right, you can divide through by the appropriate kilometers. Remember that there's 1,000 meters by 1,000 meters, a million of those meters you got to divide by 10 to the sixth. So we're looking at about 245 square kilometers. All right. Hope that helps. Good luck with your homework.